Welcome to EPG Pathshala. This is the last module for the paper of mobile computing in the subject of information technology. Though this is the last module, but the technology which we will be discussing in this module is the beginning of a new era. Before telling you about this technology, I put up a situation in front of you. A bridge in a city collapsed, lot of casualties happen. Now, who is responsible for that? Government tells that it is the responsibility, the fault of the contractor. Contractor carries forward the blame to the engineer. Engineer says that the quality control people did not do their job fairly. Quality control people says that cement manufacturer is to be blamed for. Now, the blame game as a terminating end. Now, what would the cement manufacturer say? He is saying it is fault of the cement. What? If I would have said this a decade ago, you would have declared me insane, very conveniently. But in today's scenario, it is not insane, it is smart. The cement is smart, it should be smart. The cement is equipped by sensors which could identify the cracks and then send the alerts wirelessly to fix them. If there is snow on the bridge, the sensors embedded in the cement would identify it, and then they would send this information wirelessly to the vehicles who are in its proximity using the proximity sensors. The vehicle would alert the driver to slow down, or it would slow down by itself. So, this is a communication from a sensor to an object, from object to machine, machine to machine, and machine to human. This is the exact scenario now. Bridges are getting smart, cars are smarter. Environment is smart, so are the cities. So, the fundamental shift behind this technological outbreak is what is known as Internet of Things. So, our today's topic is Internet of Things. What is Internet of Things? The Internet of Things is a system of interrelated computing devices that can be mechanical or digital machines, they can be objects, they can be animals or even peoples. Interestingly, people are also things here, who are tagged with unique identifiers which may be an IP address, a RFID tag or NFC barcode, etc. They have the ability to observe, identify, understand and transfer data over a network and convert it into intelligence without requiring human to human or human to computer interaction. So, what are the things in IoT? What is a thing in IoT? A thing in Internet of Things can be a person who is wearing a wearable device which counts the number of steps taken by him, an animal tagged with RFID tag to track it wherever it goes, an automobile that has built-in sensor to alert the driver when he is snoozing, a coffee maker that automatically starts when an alarm rings, a cell phone that automatically raises its call ring volume when it is concealed in an object or an environment like purse. So, in effect, any natural or man-made object that can be tagged and provided with the ability to transfer data over a network is a thing in IoT. According to BI Intelligence, Business Insider's premium research service, it is expected that there will be more than 24 billion IoT devices on earth by 2020. That is approximately 4 devices for every human being on the planet. And this technology comes with the tagline that anything that can be connected will be connected. So, for such a technological outbreak, the investments are also expected as well as the revenue is also expected. So, it is expected that over $6 billion will flow into IoT solutions, which includes the cost of application development, device hardware cost, system integration, data storage, security and connectivity, and in turn will bring back a revenue of $13 trillion by 2025. In our own country, telco is expecting to have 10 to 15% of revenue by IoT devices, which is only 1% now. This is according to the report of Economic Times 2017. Now, why there is the increase in the revenue expected? Because up to now the revenue was from a particular user, which is a subscriber. Now, the user is a thing. Every subscriber can have many things. So, everything in the IoT environment is becoming a subscriber and bringing in the revenue. IoT is a very hot topic now. We all know that. But what we less know is that this technology was conceived far before in 1980s, when the students of Carnegie Mellon University developed a internet Coke machine. Now, this was considered as a first internet appliance. What was this machine offering was that, now this Coke machine was connected to the internet. So, the students, before going to fetch the Coke, they used to check the status of the machine from their rooms, and if there was the availability of the Coke in the machine, then and only then they would go there to take it. Now, formally the term Internet of Things was devised by Kevin Ashton in 1999. He said, a quote, "If we had computers that knew everything there was to know about things, using data they gathered without any help from us, we would be able to track and count everything and greatly reduced waste, loss and cost. We would know when things needed replacing, repairing or recalling, and whether they were fresh or past their best." Unquote. These are the experts from its talk in 1999. Kevin Ashton is considered as father of IoT and is co-founder and executive director of Auto ID Center at MIT. So, soon it was understood that IoT has potential to change the world. This idea got materialized soon and has opened the doors for an interconnected today, which has seamlessly integrated the real and the virtual worlds. We are living in a connected environment between the real and the virtual worlds. This is what Internet of Things is about. There are sensors who are monitoring, tracking and collecting data from the things. There are applications on the clouds which are converting this data into intelligence and sending back them to the ground, where the actuators or the decision systems are taking the action based on those data. So, there is a connected environment in all and is known as Internet of Things. Now, this is the technology which became very successful in its nascent stage only. Now, 1999 the idea was conceived, and in 2007 it is not long way, right. So, what are the developments which are happening side along the conceivement of this technology, which has led to the development of its success? Factors contributing to the success of IoT are: first is wide availability of broadband internet. We all are having the access to the internet at just the tip of our finger. The cost of connecting is decreasing. There is a competition between the service providers, and every service providers is coming to provide the internet connectivity at much lower cost. There is an increase in devices which are embedded with Wi-Fi capabilities. The technologies like RFID, NFC, barcode, watermarking, that are the tagging technologies, are becoming more and more popular and are used. The sensor technology is developing. You name a purpose and there is a sensor for that. Data is getting massified, it is getting big, it is named big, and there are databases which are handling these type of big data like Hadoop and NoSQL. Now, there is a requirement of algorithms or the techniques to interpret or analyze this big data, and so the development of real-time analytics and machine learning skills is another factor which has led to success of IoT. IPv6 huge success in increasing the address space is yet another factor, because we need to tag every IoT device. Now, it is understood that this increase in the address space, with this increase in the address space, it is possible to tag every atom on the earth, and still there will be address space left for 100 more earths. The skyrocketed penetration of smartphones in our day-to-day life is also a factor. You can see from the diagram the projected data for the penetration of smartphone in our day-to-day life. So, it can be seen that from 2014 to projected data, that is till 2020, the expected increase in the popularity of smartphone is literally visible. Now, the IoT platforms like clouds etc. are also contributing as a factor to the success of IoT. Now, the basic concept of IoT, there are sensors and actuators for sensing and gathering physical parameters and the information about the environment. This data is collected by the sensors which is stored and processed intelligently to derive inferences from it on the network or the remote servers. Data collected is combined with the context information. On the basis of these inferences, actions are taken either to change the physical environment using the actuators or send virtual information. For example, controlling the intensity of road lights as per the ambient light measured by the sensors. Now, IoT is not a single technology, it is agglomeration of many technologies, and there should be some architecture which explains the different layers or the different components which form this technology. So, till now there is no one architecture which has been agreed upon universally. Many researchers are offering many architecture. So, in this module we will be considering a basic architecture which is a 3-layered architecture for IoT. And we will also just brush up the other two architectures which are proposed. So, the architecture which we will be learning in this module is a 3-layer architecture which is made up of perception layer, network layer and application layer. We will see these layers one by one, what they constitute of and how they interact with the other layers. The first layer is the perception layer. It is the physical layer. It comprises of sensors and actuators. Sensors are the on-ground pieces of hardware which are responsible for monitoring the processes, taking measurements and collecting data. Actuator is a device that is used to effect a change in the environment. Now, every IoT application has got its own requirement for the sensors. Sensors are the troops of IoT application. They are the first thing which comes into our mind when we talk about Internet of Things. The possibility of getting a sensor for every IoT application is enormous, but in this module we will just take a look at some of the sensors which are available for some of the applications. So, the type of the sensors are, you can see on the screen, we will discuss these sensors one by one. The one and the most important and most easily available sensor is your mobile phone itself. Now, the mobile phone is embedded with many sensors, like you have GPS, you have proximity sensors, you have light sensors, you have a magnetometer, and the applications on the mobile phone also act as sensor. Now, you know very well that location sensor or the GPS detects the location of the phone, it is used in the location based services. Movement sensors, that is accelerometer, it detects physical activities of the user such as running, walking and bicycling. That is the application which count the number of steps you take or the number of the account of physical activity which are doing is are based on this type of sensors. Gyroscope, these take action based or they measure the orientation of the phone and take action based on it. Light sensors, these type of sensors measures intensity of ambient light and then take actions like setting the room light based on the ambient light. Proximity sensors, they measure the distance of any particular object from the phone, and then it take actions when any object approaches the phone. Magnetometer is a sensor which can be used as a digital compass, and it is used in applications to detect the presence of metals. The applications may also act as sensors. For example, there is an application with which you can take the picture of a water body, and then by image processing of that particular picture, you can calculate the amount of impurities present in the water. For example, you can measure the chlorophyll amount, you can measure the turbidity present in the water, and so on. So, what is the application acting here? It is acting as a sensor. There are environmental sensors available. These type of sensors measures the physical parameters of the environment, like you have the temperature sensor, pressure sensor, humidity sensor. Temperature sensors are used in like agricultural industry to measure the temperature of soil water, so that it is maintained up to a particular threshold value. Similar for the industries, the temperature in the factories should be up to a particular threshold values, which is appropriate for the machines to work. At home, the temperature sensors can be used to monitor and maintain the temperature and to adjust the cooling apparatus according to it. For example, if your temperature drops below a particular level, AC should be functioning according to it. Then there is a pressure sensor. These are used in agricultural industries or in homes to determine the flow of water in pipes, to notice if there are any leakages and prevent the wastage of water. Then it can be used in vehicles or the aircrafts, the tires of the wheels of aircrafts, to measure the pressure in those wheels, because based on that the force required would be adjusted. Humidity sensors, they measure the humidity of the environment. These are used in medical industry. For example, the respiratory equipment, the sterilizers, the incubators, the pharmaceutical processing things required the humidity to be low. So, these sensors detect and then they set an alarm if it is below a particular threshold values. Similarly, for the industries, the chemical gas purification, dryers, ovens, paper and textile production and food processing units also require humidity sensors. For agricultural industry, the plantation protection, that is, it is used for dew prevention, soil moisture monitoring and so on. And in homes, it can be used to monitor the humidity in the buildings and cooling controls for microwaves, etc. Then there are medical sensors. Now, you all are very well aware of it. Like people are becoming fitness aware nowadays. So, this is the most important and the popular sensor which we are using. Now, these sensors monitor the body parameters and then they send this information wirelessly to our doctors, to our relatives and so on. And it can also be stored in a particular database, so that we can generate the reports and see that how our body is performing for a period of time. So, these particular sensors measure the parameters of body like blood pressure, temperature, blood glucose levels, then the respiration rate, heart rate and so on. Now, these sensors are available in two forms. They are available as wearable devices like in smart watches, and they are also available as tattoos or the patches which can be tattooed on the human body. Now, the sensors which are tattooed on the human body are generally used when we want to monitor the body parameters for a long time. Now, the important thing about the measurements which are taken by medical sensors is the context. For example, if a sensor is measuring the heart rate and it sends an alarm to the doctor based on the abnormality observed in the heart rate. Now, if this would work well when the body is working normally, but suppose when we are exercising, now due to exercise the heart rate will go high, and in such a situation if the sensor sends the alarm to the doctor, it would be a false alarm, because it is not considered as abnormal. When we exercise, our heart rate normally goes up. So, these sensors should also take into consideration the context information. Then there are EEG sensors. Now, these are very interesting sensors. They understand the neural signals in the brain and they infer the functioning or the state of our brain. Like suppose the brain is calm or it is wandering in thoughts, and then use this information to train the people for better attention and better focus. This technique is getting very popular in the education sector to train the students to have a better focus on their studies. And the neural signals in the brain, when they are sent wirelessly through EEG sensors, is known as neurofeedback. Proximity and level sensor. Proximity means the distance from a particular object. So, proximity sensors measure the distance from the objects. They can be used in retail areas, where a retailer can use a customer's proximity to a product to send details and coupons directly to their smartphones. They are also used for parking at public places, that is to monitor the availability of parking space in large venues like airports, malls and stadiums. Then there are level sensors which detect the level of liquids, slurries, granular materials and powders which exhibit an open surface. These type of sensors can be used in smart water management and recycling processes, where when the content is up to a particular level, alerts can be sent. These sensors are used in oil industry, where to measure the tank levels, diesel fuel gauging, liquid assets inventory, and then send high or low level alarms. They are used in agriculture to manage the water levels in irrigation. Then there are chemical sensors which are sensitive to the presence of particular chemicals in environment, in air, in water and so on. For example, the water quality sensors measure the impurities or the pH or the TDS of the water. Then there are smoke detectors which are employed at public places, which detect the presence of smoke or other impurities in the air. Then there are infrared sensors. Infrared sensors are used for proximity measurements, and they are also used to measure the heat, right. So, infrared sensors are used in smart homes to visualize heat leaks in the houses. They are used in medical areas and help the doctors to monitor the blood flow. They are used in smart environment to identify environmental chemicals in the environmental chemicals like presence of harmful gases etc. in the environment. Now, we have seen about the perception layer, and that the sensors are used to collect the data. Now, this data is huge data. So, there must be, now sensors are not able to compute or store this data. So, they have to send this data to some other entity where the information can be extracted from this data. So, for that pre-processing is required. And these are the storage resources. They analyze, store and process data gathered from the sensor. One of the most important architecture is the cloud computing environment. Cloud computing is an architecture where there is cloud in the center with the applications above it and the network below it. So, the cloud is interacting with both the application and the network, and allows the exchange of data between both of them. But the most important limitation of the cloud is that it is a central data center. So, it does not support mobility. The basic problem is that the IoT devices are mobile in nature. So, when they are moving from one place to another place, then it is difficult to communicate with the cloud data which is at a central location. And the second problem with the cloud is that the communication requires a lot of response time, and which is not desirable in latency specific applications, where the actions are to be taken immediately as the data is received, that is real time based application. Secondly, the power required by the communication with the cloud is very high, and also it offers a challenge to the IoT devices which are battery operated, and also the reliability of cloud data is also not much because it is a centralized database. So, the solution to this architecture was offered in some of the literature which is known as mobile cloud computing center. But this architecture also suffered from the problems like latency and power constraints. Fog or the edge computing is a solution to this problem, in which the nodes are distributed instead of being centralized at a particular location. Now, this is being realized by the help of a layer which is known as smart gateways. You can see in the diagram that the smart gateways are installed between the cloud center and the network. They perform the action of collecting data, pre-process and filter the sensor data. They provide compute, storage and network services to the IoT devices. They are also able to communicate with the cloud and hence send only the necessary data. They also perform the function of monitoring power consumption of the device and ensure security and privacy of the data. So, you can see here that the smart gateway is close to the network. So, what is done in this type of computing, also known as fog computing, is that these pre-processing services are brought very close to the network. They are brought as the edge of the network. Therefore, this type of computing is also known as edge computing. Now, the advantage of this type of computing over cloud computing is, you can see very clearly that it is overcoming the limitations of cloud computing. Firstly, it is a distributed infrastructure. Therefore, it is more robust because the nodes are distributed geographically, providing the services to the IoT device in its area only. It has a low latency rate because it is nearer to the network, hence the response time is very less. It also offers mobility, or it works well when the devices are mobile in nature, because whenever the device is moving, there is a mobile gateway or the smart gateway in its area. They can communicate with the cloud, hence they can send data to or from the network and the cloud. So, just not purely eliminating the cloud, just an interface added between the cloud and the network. The second layer is the network layer. The network layer is responsible for connecting to another smart things, network devices and servers. They are used for transmitting and processing sensor data. Now, there are two types of basic communication technologies. There are many communication technology we will just see, but there are two ways to communicate or provide network between the IoT devices. First as IP based and the second is non-IP based. So, the devices which communicate using the internet stack have the disadvantage that they are power hungry. Now, again this is a constraint for the IoT devices which works on battery. So, there are some non-IP based technologies like RFID, NFC, etc., which consume less power, but the limitation is that they have a limited range. Therefore, they can be used only in the personal area network. A solution or a trade-off between both the things, that is consume less power as well as provide a range equivalent to the Wi-Fi, is 6LoWPAN. 6LoWPAN is the solution to provide a trade-off between the non-IP and IP based communication technologies. So, the other technologies which are used are the key technologies which are used for communication in Internet of Things is your low power Bluetooth, Zigbee, low power Wi-Fi, RFID, NFC, wireless sensor networks. Then they can communicate via Internet Protocol Stack, 6LoWPAN, Sigfox, LoRaWAN and many more. You can just refer to your e-text to understand the functionings and the advantages, disadvantages of these communication technologies. Now, the third layer which is proposed in the 3-layer architecture is the application layer, that is the application and the services which are the use cases for the Internet of Things. but one layer has to be considered between the network and the application layer. Now, IoT devices are heterogeneous in nature. So, to provide the interoperability between them, you need to have some standards. Now, the problem is that standardization is difficult owing to the varied requirements of different application and devices. So, what should be done? Solution is that have a middleware platform which provides abstraction to support interoperability. Oracle's Fusion middleware, OpenIoT middleware and Hydra 5ware by EU are some of the middlewares available for IoT environment. Now, the last layer which is proposed in the 3-layer architecture is the application layer, and we all are living actually in this layer. So, this layer consists of the applications and the services which can be provided to the users. They are endless and they go from a level of smart cities to another level of smart homes and to the more micro level of smart bodies. Let us take a look at these applications one by one. Smart cities. In smart cities, smart parking, that is monitoring of parking spaces available in the city. Proximity sensors can be used to monitor the structural health of buildings and bridges, so that if there are some abnormal defects in the structural health, the alerts can be made to the municipal corporation. Then the noise urban maps, these are used for real time noise monitoring in the prone areas. Then electromagnetic field levels, measurement of radiations emitted by bodies such as cell based stations, nuclear plant, etc., so that they can be controlled or the alerts can be sent to the citizens, so that there are no harmful effects on them. Then the traffic congestion, that is optimization of routes based on the shortest distance or minimal traffic to avoid traffic congestion. Smart lighting, intelligent lighting adaptive to the time of the day or weather conditions in street lights. That is, these lights can adjust their lightning intensity depending on the weather condition or depending on the day. Smart waste management, automated waste collection processes which uses RFID based tags to ensure that the containers have been lifted. There is a very interesting application of this you can find on internet, that is the waste to ensure that there are bins placed over the city, to ensure that those bins have been collected. They are tagged with RFID based tags. Now, RFID technology is a tagging technology similar to a barcode technology, but the difference between RFID technology and the barcode technology is that the range is more in RFID technology and it is based on the radio waves, in contrast with the barcodes which are based on the infrared or optical waves. Hence, the RFID do not require a proper line of sight. Now, I was talking about the RFID technology in solid waste collection process. So, what is done is that the RFID tags are employed on the container and the reader is employed on the truck which is lifting those containers. So, when and only when the container will be lifted onto the truck, the tag and the reader will come in line of sight with each other, and hence it will ensure that the container has been lifted. This real time information will be sent to the municipal corporations which can generate the reports based on that. So simple, everything is being monitored. Then the trash collection routes can also be optimized based on the waste generated. There are smart roads like intelligent highways which can broadcast warning messages and diversions as per the climate conditions and accidents or traffic jams. Now, the second area of application of IoT is smart industries, where for the energy part there are smart grids which monitor the energy consumption and manages it. Then the monitoring of water, oil, gas levels in storage tanks and cisterns using the level sensors. Then monitoring and optimization of performance in solar energy plants. Measurement of water pressure in water transportation system to observe if there are no leakages. measurement of emptiness level and weight of the goods for silos stock calculations. The important application of IoT and the useful one is a smart environment. Now, forest fire detection, monitoring pre-fire conditions to define alert zones, that is the sensors will observe the fire conditions beforehand and they can send the alerts. The sensors are there to monitor the CO2 emissions of factories, toxic pollutants from vehicles and farms. These are very interesting sensors which monitor the soil moisture, vibrations and earth density to detect dangerous patterns in the land conditions to predict the landslides, earthquakes in advance, and hence can be used for landslide and avalanche prevention. The quality of potable water, that is the water which we use for drinking, can be monitored using the sensors. The leakages and waste of factories in rivers can be monitored with the help of chemical sensors. The sensor used to control the leakages and wastes in the sea, that is the sensors employed in water bodies. Similarly, water leakages in the tanks and pressure variations along the pipes, river floods, etc. The next application is in smart retail or in the retail area to manage the supply chain control with the help of taggers, NFC payment, intelligent shopping, whereas the advices are given in the point of time of sale according to customer habits, preferences, presence of allergic components for them or expiry dates. Smart product management, that is automation of restocking operations, quality of shipment conditions, monitoring of vibration, strokes, container openings or cold chain maintenance for insurance purposes. To identify the location of the item where in the big warehouses or harbors, storage incompatibility, that is warning emission or containers storing inflammable goods close to others containing explosive material. Fleet tracking, control of routes followed for delicate goods like medical drugs, jewels or dangerous merchandises. Now, the routes for these particular type of items should be tracked, so that if any anomaly is there, it can be well handled. Industries, machine to machine applications, it can be used for machine auto diagnosis and assets control. To measure the indoor air quality, sensors are used to monitor the toxic gas and oxygen levels inside chemical plants to ensure workers and goods safety. Then temperature monitoring, control of temperature inside industrial and medical fridges with sensitive merchandises, to monitor the ozone level inside the industries, then to find the location of any particular asset using Zigbee or passive tags, that is RFID or NFC. Then the vehicle auto diagnosis, that is to track the vehicles and provide advices to drivers or create alarms in case of emergencies. Smart agriculture and farming, the greenhouse very well known, to control the microclimate conditions to maximize the production of fruits and vegetables and its quality. Selective irrigations in dry zones to reduce the water sources. Study of weather conditions in the fields to forecast ice information, rain, drought, snow or wind changes. Control the humidity and temperature levels in alfalfa, hay, straw, etc. to prevent fungus and other microbial contaminants. Home automation. This is also a very popular application of IoT which is emerging nowadays. In home automation, energy and water supply consumption monitoring to obtain advices on how to save cost and resources. Switching on and off remotely appliances to avoid accidents and save energy. Intrusion detection systems, for example, to detection of windows and door openings to prevent the intruders. Then monitoring of conditions inside museum and art warehouses. Smart health, control of conditions inside the freezers which are storing vaccines, medicines and organic elements, so that they are not affected by low temperature. Then sportsman care, vital signs monitoring in high performance centers and fields, monitoring of conditions of patients inside hospitals by using the sensors to measure the various body parameters. They can be also used in old people's home to measure their health condition remotely and to inform their relatives in case of any abnormalities. To measure the ultraviolet sun rays to warn people not to be exposed in the certain hours of time. So, we have discussed some of the applications, but as I said that the applications of Internet of Things is growing. This is not a stagnant area, it is a growing area. More and more sensors are developed, more and more applications have been developed. So, we have learnt about the 3-layer architecture, and the crux of this 3-layer architecture you can see in this diagram. So, you can see the perception layer, the communication layer and the application layer, wherein the pre-process and the middle layer are between. Okay. So, you can see the sensors, different types of sensors, you can see the different type of communication technologies, you can see the different application areas and so on. Now, the 3-layer architecture was sufficient to explain the working of the IoT, but it was not sufficient to provide the information or the detailed information about the IoT technology. So, if somebody is interested in doing the research, it needs to know more detailed information about these layers. So, the another architecture proposed was a 5-layer architecture. It consists of the following layers: perception layer, transport layer, pre-processing layer, application layer and the business layer. Perception layer and application layers function similarly as we just discussed in the 3-layer architecture, but the functions of the other 3 layers we will just have a quick look at them. Transport layer, it acts as a bridge between the perception layer and the processing layer, and it transfers the sensor data from perception layer to processing layer and vice versa through wireless technologies like 3G, Bluetooth, RFID and NFC. Then there is a processing layer, which is also known as the middleware, which is discussed. It stores, analyze and process huge amount of data from the transport layer, providing services to the lower layers. It comprises of database, clear computing and big data models. And the third is the business layer, which manages the whole IoT system including appointment, business and profit models. The other architecture which has been proposed by Ning and Wang is inspired by the human brain. It is inspired by the layers of processing in the human brain. It is inspired by the intelligence and ability of human beings to think, feel, remember, make decision and react to the physical environment. It is constituted of 3 parts. First is the human brain, which is analogous to the processing and data management unit or the data center. Second is the spinal cord or the backbone, which is analogous to the distributed network of data processing nodes and the smart gateways. And third is the network of nerves, which corresponds to the networking components and sensors. So, to summarize with, in this module we learnt about a upcoming and very promising technology known as Internet of Things. We have learnt that what are the factors which are contributing to the success of this technology, which is already in its nascent state. So, we have seen various factors like the broadband internet availability, the growth of the sensor technology, the availability of the tagging technology, the success of IPv6, the availability of big databases like Hadoop, MySQL and so on. And then we learnt about the 3-layer architecture of this technology, which consists of the perception layer, the network layer and the application layer. The perception layer consists of the sensors and actuators. Sensors are used to collect the data, whereas actuators are used to take the action based on that particular data. The network layer, the communication layer, is responsible for providing the communication or the interconnectivity between the devices of Internet of Things environment, and the application layer is responsible for providing the services through the applications to the users of IoT. And the two layers embedded in between these three layers is the preprocessing layer, which consists of the cloud computing environment. We have seen that the limitations of cloud computing environment is that it is a centralized data center which suffers from the mobility of the user, it low latency rate, it demands for high power consumption and so on. And the solution to this is fog computing, which provides the communication services, computing services near the edge of the network, and it is also known as the edge computing. Fog computing is realized by the use of smart gateways between the network and the cloud center. And then another layer in between the network and the application layer is the middleware, which is used to provide the interoperability between the heterogeneous IoT devices. Then we saw that the three-layer architecture does not suffices for the detailed learning of the IoT architecture which is required in research areas. Therefore, many other architectures have been proposed. We just discussed two of the architectures. One was the one is the 5-layer architecture and the other is the architecture which is based on the functioning of the human brain. The detailed description of these two architecture is out of the scope of this particular module. You can find the references to these architecture if you want to learn in the suggested reading column of this module. So, here we are done with the paper of mobile computing. Hope you had a good time with us and see you soon.